Hey everybody, I'm just going to do a quick video, and this time it's actually going to be quick, where I'm going to show you how to use the set and reset outputs in our WindLDR program. So I've opened up my program here, and I'm going to do just a very simple instruction. I'll set an input of a, start push button, right? So let's call it start PB at I0, and then I1 I will put in a stop push button, stop PB, right? And we'll just assume, for the sake of argument, that both of these push buttons are normally open. Oops. That's not what I wanted. There we go. Normally open. Hey, I got there in the end. Okay, so we'll just say they're both normally open for the sake of argument. First thing we're going to do is go up to our basic commands. So remember, all of the shortcuts for our instructions are listed here in the capital letters, right? So a normally open or a make instruction is capital, or it's just an A. You don't have to hit capital A. It's B for normally closed. You type in out for an output, out N for an output not, which is the inverted function of an output, and then set and RST for set and reset. Now what I typically do, I'll use the shortcuts. So I'm just using shortcuts here. I'm using the A key, and I'm going to make this my start button, which is I0, right? If I want to navigate to the list of inputs, outputs, internal relays, all that stuff, you click on this little three-dot button, right? And that will pull this up, and you can navigate to whatever you need to navigate to. But I know what the address is, so I'm just going to type in I0. Say OK, and now I'm going to type in out. And I want to set output, but I can just use this regular old output, and then I can just change the type right here. So it's just another extra click, and we are good. And I'm just going to use Q0. We didn't define that earlier, so I will put in a comment here. And this is just going to be our green light that we so often use in the lab, just to demonstrate the function of this circuit. All right, so here is my set. So a button press here brings input 0 from low to high. That establishes logical continuity across this instruction, and that will change the state. Get out of here. That will change the state of our output from low to high. Okay, perfect. Now we need to have a way to turn it off. We need to reset this. So I'm going to come back over, and I'm going to drop down one with the arrow pad on my keyboard, and I'm going to do another make instruction. Hit A, bring that up. This is going to be my I1, which we made the stop. Remember, it's a normally open button, so when we press the button, the input goes from low to high, right? Where a normally closed button, it would be the opposite. When you press the button, it would go from high to low. It's just an important distinction that we need to make, right? Now I'm going to put in the output. Typed in out. There it is. And this is going to be a reset. And I'm going to use the same address that I used for my set bit. So anytime we're using a set, we have to have a reset. And the set and the reset are going to match because it's the same bit, right, that we are changing. We're think of it this way, we're switching it on. We're switching the output to high here, and we're switching the output to low here, right? But it's the same output. And if I go into my simulation, I can see that these do not have logical continuity because the state of them are low. And then when I set this, it sets it to high. That causes my output to switch on. Think about normally open push button, right? It's a momentary switch. So if I have to reset this, because that's like me letting go of the button, which is what you would do in the real world. And then I will set this stop button. That's me pressing that. And then it resets the output. Okay. So a very simple way to make a latch without any other logic beyond two inputs, two, in this case, push buttons that set and reset the same output. All right, that's it. Nice and quick, 5 minutes, we're done.